First of all, thank you to be here for this session. If you look at the title, obviously we're going to talk about OpenTelemetry and event-driven architecture. So let me introduce myself. My name is Henrik Rexed. I'm a cloud-native advocate at Dynatrace. I've been working a bit less than 3 years for Dynatrace, but I spent most of my career doing performance engineering, so optimizing things, tuning things, hitting things, destroying things. That's my passion. So I'm still love performance engineering practice, so I still try to produce, when I have time, content for a podcast / YouTube channel called PerfBytes. So if you're looking for content for performance engineering, check PerfBytes. It's been out there since 10 years. And since 2 years ago, 2 years and a half, or 2 years, I don't remember, I started a YouTube channel called Is It Observable, where I just do content for observability. So content about Istio, Linkerd, Gateway API, Ambient Mesh, anything about observability, I will try to cover it. Again, the channel is quite young, so check it out, send me your feedback. This is how I can improve on that content. So what are we going to talk about in the next 25 or less minutes? Well, a couple of things. So we're going to cover, of course, about OpenTelemetry. So I don't know how much you know about the project, so I will make a gentle reminder of a few components. And in this talk, we're not going to cover about metrics, we're not going to cover about logs, we're going to focus on traces. So we're going to see how we're going to actually produce traces, and specifically in the event-driven architecture world. So we're going to see that it's a slightly different approach, and for this, I will have to introduce the notion of span links and why it's there and the purpose of using span links. So before we start, let me tell you a story. So when I was a kid, my grandma and my mother loved to draw. So they were drawing everywhere, and I was quite not talented to that. So they teach me to take the pencil and draw things. And I thought it was quite cool, you know. There was a mythology behind the scene. And the funny story is that when I started my first job, I went in an organization and said, oh, okay, so today we have an environment, a couple of servers, we have a web server, in fact, and I want you to represent the environment. And say, oh, cool, I'm going to draw. So at that moment, 24 years ago, we're using tools like Nmon, Top. I'm pretty sure you know those. They are very precise, but they give you points, data points. So I took the data, and then I tried to represent the environment. And I was able to draw this. It's a bunch of points. So if you have the points, you can say, oh, maybe I'm zoomed in so much that it's like a bunch of pixels. Very hard to understand the actual idea of what I was trying to represent for these organizations. So that's the web server at that time. Then 20 years ago, we had storage. So the data that we were collecting on those solutions were stored. That was one good sign. And then after that, we were adding metadata. So SMDB data, where you know which server it is, which service it is. So then you have more context related to that. So instead of having just points, I was able to draw lines, attach those lines. So now you can see that the server has a better shape, but again, it's very hard to understand the actual situation. 13 years ago, this is where we have lots of application performance monitoring solutions, so APM products coming on the market, providing distributed tracing, metrics, a lot of different various features to let you understand what's going on the system. So with this information, it was much more easier to represent things. So I had at least the eyes, the mouth, the nose of the server. So at least it was much more easier to understand the context. And then 10 years ago, we had so much logs that we started to index those logs. That was great, but sometimes logs is great, but you're polluted by logs, and you try to do things with this, so we tried to use it, and at the end I was only able to add 2 arms to that server. But what did I want it to represent? I wanted to represent this server, so it's a kid, wearing clothes and sitting in the middle of the park. So with the tools that I had at that time, I was not able to represent the environment, the context, the situation. And this is, observability is a bit like art. You give the tools, with the tools, you're able to understand where you're facing, the surrounding of your servers, the surrounding of your applications, and then you can draw, you can paint whatever you want. So let's cover the various artistic tools, the pencils, the pastels that we have in our hands today. So, as you know, observability has different pillars. So we have logs, we talked about it. So this has been out there since many years. We have events. So a system like Kubernetes is throwing tons of events, and events is quite cheap to store, but very powerful. And then don't only limit yourself to events in Kubernetes. When you build your systems, when you deploy your systems, there are events generated out of that. So if you send those events in your observability solutions, then you get so much rich information that will help you to troubleshoot. Metrics, of course, we talked about it in previous talks, no surprise. Then we have traces. Traces is very popular since a few years, since the emergence of open tracing and OpenTelemetry. Traces is a great start, but usually when you have a problem, you will jump into profiling. Profiling is where you're going to figure out what is causing the CPU time, what is causing the memory. So profiling is very, very powerful. But observability pillars are great, but without context, it's useless. You need to attach to the data the technology that you're dealing with. Which server, which application, which version, which location, because we're potentially deploying everywhere in the world, so we want to figure out if it's East Coast, West Coast, Europe, whatever it is. And then with that context, with that metadata, we can start analyzing. Cross signals, and that's exactly what we're looking for. But there is a situation that happened a few years ago, is that in the observability world, there are solutions that are specialized. We have specialized solution for metrics. You have specialized solution for logs. You have specialized solution for traces. And as a reaction of that is that the market has started to isolate the signals. So I'm going to store the metrics in Prometheus. I'm going to store my logs in Elasticsearch. I'm going to store profiling data in Parka, for example, and so on. So at the end, we are separating things, and then when we troubleshoot, we are not efficient because we have to go one place, and then we have to go another place, and then you have fire, but you say, hey, 2 seconds, I have 4 solutions to deal with. So stop doing this, bring everything together, stop separating things, and think about that you're going to need those data when it's going to be under fire. So be efficient is very important. And that's the purpose of the project OpenTelemetry. OpenTelemetry is an open standard, allowing you to create, in a standard way, metrics, traces, logs, soon profiling, and it doesn't provide any observability storage. It's just standardizing the way you're going to build your signals. So vendor-agnostics. If you want to summarize the project, you have in one hand the instrument. So I'm able to produce metrics, I'm able to produce traces, I'm able to produce logs, so I will have sound coming out of my code. That's wonderful. And then there's an optional component called the collector. But in fact, you will see that everyone is using that component. And that component is like an amplifier. So I receive the signals, and then from the amplifier, you can put some overdrive, some chorus, so I can modify the signals. And then I can amplify it to send it to any destination that I want, to Dynatrace, to Prometheus, to whatever you want. As of now, if you look at this project, metrics and traces is super stable. You can use it without any problems. Logs is going to be stable in a few months, so keep an eye on it. A unified way of creating logs and a structural way of creating logs, that's exciting. And then we have continuous profiling where the specification is on the way, so we should expect it next year or maybe a year and a half. So let's cover how we produce traces. So produce traces, you can do it manually. So most of the time, people say, manually sounds quite expensive. But if you have a fresh new app, it's not so expensive. It's like producing logs. We used to produce logs when you build our code, so why don't we start producing traces? But the natural reaction is not use manual instrumentation, it's use automatic instrumentation. So we have agents or semi-automatic agents where you add libraries, and then from there, you will instrument well-known framework of the market. And then let's ask yourself, what is actually a trace? A trace is a transaction in our system. Our system will hit different components, and every step of the transactions methods will be considered like a span. So basically it's a JSON object, an array of a JSON array of spans, where we'll have a couple of informations. The way we attach each spans to a trace is with the help of a context. The context is the trace ID and a span ID. And with that, this is how we attach everything. You will see it's very important, trace context, specifically in the event-driven architecture world. We're going to cover that in a few seconds. So what is the journey to instrumental code? I take my code, I add the OpenTelemetry API SDK, and then if it's automatic or manual, you will have those objects. I will have to create a trace provider. The trace provider will determine how those spans will be sent to the backend, where I'm going to send it to the exporters. The resource will be the passport, the identity of my service, and the sampling, how much data I want to send over to the backend. And then we have the propagator, so we're going to cover in details the propagations. And then once we have that, we can create spans, and this is what we're looking for. So resources, I'm going to cover it. We talked about it. Let's cover the sampling. The sampling determines how much data we're going to send it, and you will see that it brings a challenge when we're going to cover the event-driven architecture aspects. So sampling, that we have at the moment, OpenTelemetry provides a couple of sampling decisions. So at the moment, you have to configure it yourself. Maybe in the future it will be different. But as of now, we have always on, means 100%, but it will be very expensive. Always off, nothing. You have parent base. Parent base means I will only send if I'm involved in a call. So it's perfect for service B's, D, E, and C in this example, because I don't want to have the health checks. Doesn't make sense. In my trace, it will be expensive for nothing. Then I have the trace ID ratio based. I put a percentage of how much data I want to send, and it will send that percentage. And then we have a combination of parent-based and the other. So parent-based always on, so parent-based 100%, parent-based trace ID ratio, parent-based always off. So if you take an example here, so we have a service A configured in trace ID ratio 50%, service B in parent-based trace ID ratio 25%, and so on for the rest of the dependencies. If I set 50%, 25, 10, and so on, I just came up with random numbers, all right? So if I have 1,000 requests coming in our systems, it means that only one request out of the 1,000 would have a trace from A to E. So you have to figure out, don't improvise the numbers, think about the details you need. Propagation. Propagation is the systems on how the trace will be attached to each other. So I start a trace in service A, so the OpenTelemetry component has been initialized. So the trace context will be, of course, propagated, no problems. But how can I make sure that the trace will continue on service B? Well, this is where propagation comes in the picture. So the service A will inject the trace context. So in the case of HTTP, it's going to be header, very easy. And then the service B will extract the trace context. And once it has extracted, it will then continue the trace and we'll have everything. Why I'm saying this? For HTTP, it's quite standardized. But if you look at event-driven architecture, it's not super standardized. So for Kafka, it's going to be part of the headers. If you look at IMQP, it's going to be from the application properties. So every system, messaging system has defined the way they're going to add their trace context. So again, there is no unified way of doing it. So that's a bit of a mess. So figure out which technology you're using to pass properly the trace context. Otherwise, if you don't pass the trace context, you will have one trace on one end on service A, and then another trace on service B. And then the context is not attached, so then you don't have an end-to-end trace. So in a traditional microservice architecture, the tracing is awesome because at the end, if you take this an example, we have an ingress service calling another services, and with the trace, I'm able to keep track of what's going on my components, and visually I can see where I'm spending time. So here I have a 25 milliseconds transaction, and if I want to optimize that transaction, I can clearly see that I have a 20 milliseconds time spent on this list recommendation, so I can optimize that methods. I will reduce the time of the overall transactions. And then the other aspect is here, I can see that get product is called 5 times or 4 times. So maybe there's another way of doing it a more smarter way. So it's not really rich to figure out where you're spending time and how you can reduce them. So now you're going to say, okay, great, but it's just microservices component. What's the relationship with event-driven architecture? Well, okay, let's cover that. So In event-driven architecture, you have maybe microservices sending gRPC or HTTP requests, and suddenly you send a message to a broker. And then once the broker receives it, so you're a publisher, and then you have consumers. So you can have 1, 2, 3, 4, or X consumers consuming that message and doing tasks. So you can have several options. Either I can do a full end-to-end trace. That's one option. Or the other way is let's separate the traces. Again, there's no answers on what you should do. You have to implement it. So let's cover 2 examples. The first example we're going to do is end-to-end trace. So I've prepared a GitHub repo. You can figure it out here. So I have the OpenTelemetry application just to make some traffic. And I have an namespace called event-driven architecture where I have a publisher and 2 consumers. And then I have the OpenTelemetry collector that sends it back to Dynatrace. And then using Solace, which is a messaging mesh that can deal with the brokers and different brokers from different environments. So just as an example. So as a consequence, let's have a look at it. So I have the publisher here. So I recorded a demo. I'm quite lazy. I'm sorry. So here I got a publisher. The first thing that you can see here, I have the publisher and 2 consumers in the talk. Let's have a look at the publisher. And the publisher, you can see, first of all things, what I'm doing is I'm adding the OpenTelemetry API and SDK because I want to create manually my traces. Then I have defined my trace provider, the OpenTelemetry exporter, so the standard one, and the batch span processors. And in this case, I can create, once I have defined that, I can create easily spans without any problems. But in the constant event-driven architecture, I need to extract the trace ID and the span ID. Because then, in the broker, in my case, I'm using Solace, I'm adding in the message property my trace ID and my span ID. Why I'm doing this? Because I need a trace context. If I don't do that, it means the consumer doesn't know that it's part of the trace. Now let's look at the consumer. The consumer is similar things. We'll have, of course, the OpenTelemetry API and SDK. We'll configure the trace ID provider, the exporters, and so on. But in this particular context, here, the first thing I'm doing here, I'm extracting from the message the trace ID, and I'm extracting from the message the span ID, and then I would be able from there to create the span context, or the trace context. And then once I have the span context, I will be able to create my spans with that context. As a consequence, we look at Dynatrace, I will have the 3 services, so the publisher and the 2 consumers. And if I click on one of the services, let's say this one, for example, the RESTs, with the details of the trace, I will have the response time, the failure rates, the throughput, all the dependencies, and so on. So now what I want to do is, I'm going to speed up a bit this video to figure out, I have an example of a trace. No, where is it? This is my mistake. I should not have speed it up. I went back. Where is it? Oh, here. So here we have the results of the trace generated. You can see that we have the publisher starting it. He has some details about what happens on the publisher. And then we have 2 consumers. So every consumer is attached to the same trace. So if you look at that trace, you can say, okay, great, we have all the details, but it's a 2 minutes trace, a bit too long, also for my talk. And I can see the details of the consumers, but I don't see anything about the publisher because it's 200 milliseconds spans. So as a consequence, this trace, it may not be useful. So by looking at it, I may not be able to troubleshoot properly when a thing is happening in production. That's why we have another option called span links. Span links, the purpose is to split this 2 minutes trace and create 3 traces. 1 trace for the publisher and 1 trace for each consumers. And I will add a link from the consumer's perspective that will link back to the publisher. This is how we can then get back to the publisher if I need it. So let's do the same thing. The difference with this demonstration, the consumers as a difference, similar to the previous demonstration, will extract the trace ID, the span ID. But here, we will create the span context, and then instead of attaching it previously, we create a link, and you can see on the right, we have a link to that span, which means all the spans attached to that trace will be linked to the previous publisher trace that we had. So I don't want to look at everything. We have the same results, but let's look at the generated trace that we have. We'll have it in a few seconds. Here. Oh, I should have done that. Here. So here, as a consequence, what we have is, oh, great. Awesome. As a consequence, if we look at the trace, if I can find it. Ah, never mind. I'm losing time for nothing. Yeah, as a consequence, what you can see is that I have 3 distinct traces, but I have a link, which means from the consumer perspective, I have the link of the trace ID. I can jump to the publisher and get the details. But there's one constraint. You don't have the link from the publisher to the consumers. You only have one consumer to the publisher and not the opposite. So there are pros and cons. Span links, first of all, is a way of improving the visualizations. So you can keep track on which consumer has been called by what. So you have the dependency on who has generated that message. That's great. It's improved the visualizations. But the big constraints of using this is that you're losing the relationship between the publisher to the consumers. So if you're looking at how many consumers has consumed my message, then you will have to figure out a way of doing this. The other big downside is sampling decisions. This is why I mentioned sampling. If your publisher has been sampled, the trace, but your consumer has not been sampled, you will have a link to nothing. So that will have some negative impact. But again, this is just to tell you that if we give you the tools, the pencils, the pastels, you will have to understand your system. And depending on how your event-driven architecture has been designed, maybe an end-to-end trace will be perfect for your applications, or maybe not. So using span links will resolve it. So there's no clear recommendation on how you should proceed. You'll have to understand things, control the tools, and to be able to produce the right observability that you need for your environment. So as a takeaway, instrument, don't put any vendor libraries, put your code agnostics. It will be simplified to maintain your code in the future. So OpenTelemetry is great for that. In the observability layer, don't produce observability without metadata, without context. Like I said, if you don't have context, I mean, it's going to be useless. Make sure to add the right context to your data, otherwise you won't be able to utilize it properly. And be creative, understand your systems, and design the observability that you need depending on how your application works. There is no standardized approach. Small teaser, so this is the YouTube channel. Check it out, it's out there. And this content comes from one episode, so if you want to go deeper on this context, you can go on the episode related to that. And if you have any questions, I'm open for that. Yep.
Thanks. One question about the traces. Does it make sense, or is it possible to derive, like, how do you summarize a big bag of traces into a higher level? Like, would it make sense at all to derive metrics from the traces?
So that's an excellent question. So like a trace is at the end, any observability solution, when they store the traces, it's going to be stored into like a storage. There are solutions like Honeycomb, for example. Lightstep is doing it. Dynatrace is doing it. We have specific query language where we can query the spans, because the spans at the end is part of a trace. And then if you can join it, you can create metrics out of that. You can say, I want to generate, for example, the response times. If you saw in the demo, I was quickly on this, you saw response time, failure rate, throughput. This is not generated. It's just we take the data from the spans and we extract that data. So at the end, with traces, you can generate response times. You can generate, I don't know, sometimes you have events. You can measure how long it took to, for example, to achieve the payment of a given transactions. So you can do tons of things with that.
Any other question?
By the way, I have an example, but not here. But even with traces, you can even think about doing business analytics. Because if you report back some spans attribute or source attributes or span attributes, that are meaningful. You can count the number of orders per split it by zip region. You can be creative. Depending on what data is part of the trace, you can imagine to report more than just technical aspects of your system.
Hi, I'm Chaitanya Amin. I think this is a wonderful talk, and I really enjoyed it. One of the problems which are faced in observability is that, let's say that you have a microservice architecture and you have more than one languages, like say something in Node.js, something in Python, etc. It becomes very difficult to have a common implementation for observability because the knowledge doesn't transmit to the different teams.
Yeah.
Is there a way you can abstract away all the tracing to something like a sidecar or something of that sort where it becomes easy to...
So if you look at the, on the OpenTelemetry project, there is the OpenTelemetry operator that simplify the way you deploy the collector and so on, but it has an instrumentation CRD. And then you can say, okay, so I'm going to instrument, this is how my sampling decisions, blah, blah, blah. And then in your workload, you say, oh, this is a workload in Node.js. This is a workload in Java. So you have to add specific annotation in your deployment files. And then what would happen with the operator will add an init container that will add the right instrumentation agent for Node.js, Java, Python, .NET, and Go. Go, yeah, it's recently added in Go. And C++, I think, has been added as well. So if you have, for example, an Nginx ingress controller, they're trying to also automate the injections of the agent for your ingress. So then you have a full end-to-end trace with everything. And in the previous talk, you focused mainly on Istio, yep, on the metric side, but Istio now support the W3 trace context, which is the common one for OpenTelemetry. If you just enable tracing in your sidecar model of Istio, you should have for each envoy the trace, which means if I didn't instrument anything, I get every call for every systems. That's a good start, but again, there's a balance. I get the details, but it's going to be quite expensive. So there's always a balance. How much details do I need for the right cost?
Understand. Thank you.
Welcome.
Yeah, I think we don't have time for more questions. Thank you so much for the talk.
Welcome.
This is off topic. I think the OpenTelemetry group have a task group, and they are building a query language to query logs, tracing metrics.
So it's a unified query language.
Yes.
I'm part of the group. At the moment, we are doing just... Oh. So if you do it, at the moment, we are doing an inventory of all the different query language. So we are covering Prometheus, Dynatrace, Lightstep, OpenSearch. And the idea is to represent what is actually present. And then we wanted to build a unified query. The idea is that we are not going to force every vendor to change their query model. Is that potentially in the future there will be like a sub-layer in the front that will talk to that unified query language. And then that component will translate to the right language, right observability solution.